This is an application of magnetism question, and you are told that we bring an unknown object near to the magnet. The magnet is placed on the weighing balance, and when we move the unknown material near to the magnet, the reading actually drops. So when the reading drops, we must conclude that this unknown material is either a magnetic material that has not been magnetized yet, for example iron bar, or it can also be a magnet with its south pole at the bottom, attracting the permanent magnet. So how can we reach this conclusion? We start from the info that the balance reading has dropped. This must mean that the magnet is now being put upwards, which therefore results in the balance reading becoming smaller and smaller. So what can possibly pull the magnet up towards the top, towards the unknown object? If the unknown object is a normal iron bar, which is a magnetic material, the magnetic material and the permanent magnet will attract each other. That will pull up the magnet, therefore lowering the balance reading. So that's the first answer. The unknown object can also be a south pole at the bottom. Two magnets, unlike poles, will attract. Therefore, this will pull up the permanent magnet on the balance. So I've illustrated the second scenario using an electromagnet. It can actually just be another permanent magnet with the south pole at the bottom that will result in an attraction that pulls up the permanent magnet on the balance. This is a question on solenoid, electromagnet, and also we have to apply our right hand grip rule in this question. So you are given that the reading on the balance decreases when the electromagnet is switched on. So therefore, identify the direction of current within the electromagnet, and also give two modifications to the circuit for the effect to be greater. So I will start with the easier part of the question. That if for the effects to be greater, basically we want the electromagnet to be a stronger electromagnet. So what can we do? So standard ways of doing so, either we increase the current flowing through the coil by using a higher EMF for the battery, or we can just increase the number of coils for the solenoid. Now, direction of current, we must first recognize that the bottom part of the solenoid is north pole of the electromagnet. This will result in a repulsion that pushes the permanent magnet down, increasing the reading of the balance. And therefore, the top part of the solenoid must be a south pole. That is where we use our right hand grip rule and point our thumb towards the bottom, towards the balance. And with that, we can then identify how the current must flow in the electromagnet so as to create a north pole at the bottom of the electromagnet.